For this exercise today, we're going to look at a cantilever beam, but this time with an angled load. So we need to use a few things that we've done before. The first is to separate that load into components, and after that, find the reactions just like we did in the previous exercise. Let's get to it. So here we have a cantilever, we have a fixed supporter A. That means once again we have two support forces that we need to find and one reaction moment that we need to find. At B we have an angled force of 5 kilonewtons. Before we move on to drawing the free body diagram and finding those reactions, I first want to look at that force. Now we can see here that it's a magic triangle, right? One of those 3, 4, 5 triangles. And so if you can see that, then it is pretty easy to find the force. Let's start off with that. So if this is my 5 kilonewtons here, and I recognize that it is a 3, 4, 5 triangle, it's pretty easy because that one is already 5, then I can see that this force Fy is going to be 3 kilonewtons, and this force here in the x is going to be 4 kilonewtons. Now, say I didn't see that or I didn't recognize the triangle, let's look at it in a different way. So once again, I'm just going to draw out my 5 kilonewtons here. I know that I have a force of Fy and a force of Fx. And what I do know from looking at the triangle is that I've got this triangle. I've got 5, 3 and 4 here. If this is alpha, I can say that tan alpha is 3/4. If I do inverse tan on my calculator, I find out that alpha is 36.86 degrees, meaning that sine alpha is 0.6 and cos alpha is 0.8, and therefore since this is alpha, Fy is 5 sine alpha, which gives me 3 kilonewtons, and Fx is 5 cos alpha, which gives me 4 kilonewtons. So two ways, either recognizing that triangle or just finding what the angle is and then solving the components like we've done many times before. The next thing that we want to do is draw out our free body diagram. What I'm going to do here is I'm going to already put the forces in their directions. So we had 3 kilonewtons going this way and we had 4 kilonewtons that way. I'm going to draw out the force reactions now. So I've got AX, I've got AY, and I've got MA, all drawn in what I consider to be the positive directions according to my sign convention. Now, if you recall, because AX, AY, and MA are on different axes, they are not going to influence the results, and I can start wherever I want. I'm going to start with sum of forces in the x direction equals 0, with this being my positive direction. So I've got AX, and then I've got minus 4 equals 0, so AX equals 4 kilonewtons. Moving on to solve the sum of forces in the y direction equals 0, with this being my positive direction, I've got AY minus 3 equals 0, so AY equals 3 kilonewtons. And the last thing that I want to do is sum of moments around A. So once again, I'm choosing A because my two unknown forces AX and AY pass through A. I can also see that the 4 kilonewtons at B also pass through A. So really all I'm left with is this 3 kilonewtons here that can contribute to a moment and this concentrated moment here. So MA at A is positive, and then I've got that 3 at B creating a clockwise or negative moment, so minus 3 times a distance of 2 equals 0, and therefore MA equals 6 kilonewton meter. Before I do my check, I'm just going to quickly draw everything in. So starting off with AX worked out as 4 kilonewton. It turned out positive, which means the direction I assumed is correct. AY was 3 kilonewtons, once again positive, so the direction I assumed is correct. And MA also came out positive, once again meaning that the direction that I assumed is correct, and that is 6 kilonewton meters. So first things first, let's do a quick sense check. I'm going to first look at this balancing. So I can see that in the x direction I've got 4 balancing out 4 at B. In the y direction I've got 3 at A, which is balanced out by a 3 at B. And I've got this moment. Now if I have a look at point A, I can see that that 3 kilonewton at B is going to create a moment going in this direction. And to counter that, I can see that this moment of 6 goes in this direction. So they are balancing each other out in direction. Let's do one last check just to make sure that they're also balancing each other out in value. So to do my check, I'm going to do sum of moments at B this time equals 0. So the two forces at B are not going to contribute. That 4 kilonewtons at A is also not going to contribute because it passes through B. There's no distance in Y from the line of action to B, so there's no moment there. So what I do have is my 6, which gives me a positive moment, and then the 3 at A, which gives me a negative moment, times the distance of 2, and that is indeed 0. So not only is everything balancing out in direction, it's also balancing out in value. And that's it. We've found the fixed end reactions for a cantilever beam with an angled load. We now can move on to discuss different kinds of loads mixed together on both these types of beams. Join me to do that. In the meanwhile, bye for now.